Good evening, everyone. Thank you for joining us once again for Weather Wise. I'm meteorologist Liam Healy.
And I'm meteorologist Christine Gregory.
We have another great show planned for you tonight as we talk about a weather event that we see quite often around here in Oswego during the wintertime, lake effect snow.
And if you love snow, don't go anywhere because we're also talking about some other wintertime topics in our Twitter questions and in our segment, Weather Myths Debunked.
We'll get to all those details after a brief break. Stay tuned. We'll be right back.
Welcome back, everyone. Now, before we get to our show, we would like to take a brief moment to talk a little bit about ourselves so you can get to know us just a little bit more. So, Liam, tell us how you first got your start.
My big thing has always been nor'easters. I grew up down in southern New York, so we always get those big nor'easters. You get the big rain-snow line. You're going to get snow. You're going to get rain. That's what always fascinated me. So, I mean, it's been a pretty interesting journey to get here. I started out at a different school, and now I came to SUNY Oswego. Been in TOP for 3 years now. Never regretted a second of it. So it's been a great journey. I love the weather. Can't beat it at any time. It's always great. Even up here in Oswego, it's never a dull day. What about you, Christine?
Well, I grew up in central New York, so not too far away from here. I started off as a freshman, and I joined WTOP as a sophomore. So I've been doing this for a few years now, and it's actually been a really great road ahead. I love severe weather, and I really hope to talk more about that in the future. But we are talking about lake effect snow in our Weather-Wise topic of the week, so we'll get more on that later.
Yeah, so actually, let's get into some of our wintertime topics with our Twitter questions. Joining us now on set is Dan Meslowski for hashtag Ask a Meteorologist.
So Dan, what is everyone curious about tonight on Twitter?
Well, our first question comes in from Ben Shriver, and he's asking, how do mammatus clouds form? Well, mammatus clouds form when you first have warm air rising within a thunderstorm. This is called the updraft, which feeds the storm the energy that it needs to survive. As that warm air rises up to the top of the cloud, it cools and expands. When the air cools down, it eventually becomes more dense than the surrounding air and therefore begins to sink. This sinking motion carves out those spheres, or bubbles as I like to call them, which are known as mammatus clouds. Our second question comes in from Timothy, and he asks, why does the salt used on our roads work best to melt the snow and ice when the temperature is warmer? To answer this question, we have to look at some of the chemistry behind it. Water freezes at 32 degrees Fahrenheit or 0 degrees Celsius. When you have snow or ice on the ground, especially on a cloudy day, it's not going to melt unless the temperature outside is warmer than the freezing point. To make it melt, we add road salt, which has some interesting properties when applied to snow or ice. Your average plain road salt allows for snow and ice to melt at temperatures colder than the freezing point of 32 degrees Fahrenheit. So if it's 30 or even 25 degrees out, adding that road salt will melt the snow and ice. The reason why it works better at warmer temperatures is because, just like a lot of things, road salt has its limits. If the temperature gets really cold, like around 10 degrees Fahrenheit, the road salt won't be able to melt that snow and ice unless certain chemicals are added to it. Keep sending us your questions on Twitter, and we'll do our best to answer them all. Back to you guys at the desk.
Thank you, Dan. That was really interesting.
Yeah, I mean, you always wonder why they're always putting so much salt down. Or even that brine solution that you see when they try to preemptively do it, that brine solution actually helps to put a little water on the road, which helps to activate the road salt more, so you can melt the snow and ice on the road up to a lower temperature. So thank you, Dan, for all that information. We'll be right back. We'll have weather highlights in just a few minutes.
Welcome back to Weather-Wise. At the Weather Wall right now is meteorologist Liam Healy. So Liam, what's going on outside of our neighborhood?
There's actually a lot going on this week. And not all of it's weather. So we're actually looking at the Indonesian earthquake that happened on the 28th. That was this Sunday. So it happened at 9:04 CST. It was a 6.8 magnitude earthquake. Thankfully, much unlike the earthquake that happened a year ago, this one did not produce a tsunami. like that happened with the Palu region of Indonesia. This happened in a different region of Indonesia. It's a very large island chain. But we did see it was a devastating earthquake. It was picked up by 15 different seismic stations at a depth of 31 miles below the earth. So thankfully that low, when it's so low, it's not going to do as much damage, but at that strength, you really are going to see a lot of damage across the area. And even in California, again, we're seeing a lot of wildfires across the entire area of California right now. So there's a couple different weather conditions we really want to look for. So we're looking for dry vegetation, low humidity, and those winds to really be picking up. As those winds really rake across the entire area, it's going to wick away that moisture even more. And even a couple fuel sources, a heat source, whether it's an old campfire, you even see PSE&G over in California has now been cutting power to people because they've been accused of starting one of the most recent forest fires from a couple months ago. So you need heat source, fuel, and oxygen. Your fuel is generally those forests, those big trees and everything. You even see some other examples, prairie grass, brush. A lot of dry brush out there in California. And all it takes is just that one little spark to really get everything going. So really, you see those winds, and that's what's going to pick it up. A really big cause of this are these Santa Ana winds. They're a climatological feature of the Southern California area. So you see the air is going to descend down the mountains. You're going to get a lot of low humidity as this air is starting to heat up. The humidity content as the air heats up, it's able to hold more water. So as it heats up, there's less and less percentage of water in the air as it's moving around. So that's going to cause this air to dry out. And that's why this area is so prone to fires. And that's especially what's happening right now. They're having one of the worst Santa Ana outbreaks in over a decade. So these are the lists of some of the current fire warnings across California. A lot of them are especially located down here to the south towards Los Angeles. A new fire actually sprung up just this morning. That's called the Easy Fire. So these are actually a list of all the current large incident fires in California, as well as some of the entire area. So now let's just take a little quick of our local checkup here. We see this is the November, December, January outlook for the entire East Coast. We're looking for a little bit of a warmer than average winter, but remember our average temperatures for our area at least are in the 20s. So you're not going to be seeing somewhere like, you're not thinking 50s, you're thinking more like maybe upper 20s into the low 30s for those warmer than average temperatures. And we see this rain which is moving in. That's going to be a big problem for Halloween. You can tune in a little bit later for Dan Maslowski's secondary final weather check and just coming up at the end of our show. You're watching Weather-Wise. We'll be right back in just a few minutes.
Welcome back to Weather-Wise. This week's topic is lake effect snow, and me and Liam are going to break it down for you one by one. So, Liam, many of the folks here at home have experienced lake effect snow, but could you tell us a little bit about what makes this region experience this unique phenomenon?
Well, really what we're watching for is, you see, we have the largest areas of fresh water in the entire world right here. These Great Lakes hold 5% of the fresh water, and that's really what drives our massive lake effect snow across this entire region. Let's focus in a little bit on these snow belts. These snow belts are the areas that these lake effect snow these regions that surround it, the Great Lakes, that receive the highest amounts of lake effect snow. So as we talk about these regions surrounding the lake effect, these areas around the lake effect, so we look at Erie and Ontario. These are our two local lakes. So these regions surrounding these Great Lakes are the heaviest areas of snowfall for our areas. And if you take a look really at what that means in a quantitative sense, we're looking at anything over 80 inches here. So look at how well that lines up to our snow belts that we had there. So the average annual snowfall over our area, right here in Oswego County, we look at anywhere between 120 to over 140 inches per year when it comes to lake effect snow. So what really we're talking about is these heavy lake effect snow accumulations, and we have this really big area of 140 inches due to what's known as the Tug Hill Plateau. It's a geographic feature here that we really rely on to help provide orographic lift, which just means that it provides extra lift to the air that's coming off of the lake to produce that heavy snowfall area. Christine, what really helps make the lake effect in the first place before we can even have this massive snowfall come into the area?
Well, lake effect snow tends to occur mostly during the late fall, winter, and spring months. Now, why is that? Because during the winter, the land becomes much colder while the lake remains warm over the summer, because the lake has a higher capacity to hold in that heat from the summertime, and the land cools down much faster. So this phenomenon occurs when cold air flows over the relatively warm water. This is what produces all that convection and the clouds as a result of the moisture inside the lake. And then the leading wind stretches these cloud bands across the neighboring lands. And it's these long, narrow bands that produce extremely heavy snow at times and creating very localized impacts. Now, let's take a look at some basic lake effect criteria. So we're going to break it down. And first, you can see that lake effect stretching across the lake. So here's what you need. You need a large fetch across the lake, which Liam will talk about what that is in just a moment. You also want weak shear from the surface to the boundary layer. You also need light winds in the boundary layer because you don't want a lot of shear to break up those snow bands. And you really want a large atmospheric temperature difference, which again, Liam will talk more about that in just a second.
So Christine, real quick though, what is the boundary layer?
So the boundary layer is an area above the lake in which the temperature is a lot warmer than the lake surface. So that's how you get those lapse rates, which you could talk about.
So we're going to talk a lot bit more about that. That boundary layer also has an area of where friction is still impacting the air that's crossing over the lake. See, with the lake though, you don't get a lot of friction just because it is mostly a frictionless surface, at least the surface of the water. As you get off the land, that friction does increase. So the fetch here is the distance that the air travels over the lake. So the more that the air travels over the lake, the more moisture it's going to be able to receive from the lake. So with that warm water, it's releasing that water vapor. And as the air comes across, you're looking at more and more water vapor being collected so that you can get heavier lake effect snow. Our ideal fetch is 75 plus kilometers. So generally when we talk about our scientific topics, we talk in the metric system. That's just it's international standard. It makes everything a lot easier for us, at least. You're looking at probably somewhere close to about 100 miles. So generally looking for areas of 75 plus kilometers to get that max amount of water vapor for the area. So when we're talking about shear, we're talking about from the surface to the top of the boundary layer. So that boundary layer is going to be indicated by this line right here. So we have two different types of shear. We're looking at directional shear, which is as the wind changes direction with height. So what you're really looking for is less than 60 degrees change in the wind direction from the surface to the top of the boundary layer. The top of the boundary layer is probably anywhere between 2 to 3 kilometers on any given day. So what you really don't want to see is the wind direction changing too much, or else you're going to lose that water vapor when you're coming across on your fetch. And your speed, you don't want the wind to be too strong. If your wind is too strong, you're going to see the moisture moving too fast and not having time to condense and create into that lake effect band. And again, as Christine talked about, we need a distinct temperature difference for this lake effect snow to form. So we want something that's known as a lapse rate. For every kilometer we go above the surface of the lake, we want to find a 13 degrees Celsius temperature difference. And that's about 18 degrees Fahrenheit. So if you're taking it in our terms here from the United States system measuring, look at 18 degrees Fahrenheit per kilometer as we go up in the atmosphere. And really, it's that lapse rate that really helps that air begin to rise and really begin to move. And one last thing is that we have two main types of lake effect snow. We have a long lake axis parallel band as well as a multi-band. The long lake axis parallel band is going to be what really brings us the heaviest snow. The multi-band tends to be weaker and a little bit more scattered. So really, we want to see, if you're looking for those big snow totals, you're a weather ghoul, as some may say, you really want to have that long lake axis parallel band. So Christine, what are some of the other things we need to worry about during lake effect snow?
Well, lake effect snow, as you all know, has tremendous impacts. So why do we really care about lake effect snow? So this snow event, when it does occur, can create extremely local and intense events due to the fact that it's such a skinny band and occurs at a short height above the surface. It's also, again, a very narrow and changeable band. So the wind plays a huge role in this. So at any time, if the wind shifts direction just a little bit, these bands can move just a few miles to the south and create extremely dangerous conditions. And again, wind direction plays a key role in where these lake effect bands are going to set up over your area. And again, the sun could be out in one town while whiteout conditions are present in the other. So it's really important to know where these lake effect snow bands are going to set up so that you can stay weather-wise about your situation.
Well, that's all the time we have for our weather-wise topic of the week this week. Coming up just in a little bit, we're going to be talking about our weather myths debunked. It's going to be about the woolly bear caterpillar, something you may have heard about growing up.
We will be right back.
Welcome back to Weather-Wise for our last discussion of the night, weather myths debunked.
Joining us today to help discuss our myth is meteorologist Bethany Strong. So, Liam, tell us a little bit about what we're going to discuss today.
All right, so like I just said at the end of our last segment there, this week we're tackling something you might have heard about growing up, the woolly bear or fuzzy bear caterpillar, depending on exactly where you live. Can it really predict the winter and what it will be like? That's a pretty interesting concept there. It's much like the groundhogs, you would say.
It's a little different. But so legend has it that the larger the black bands on this caterpillar, the longer, the colder, and more severe the winter is going to be. Similarly, the wider the brown band on this caterpillar predicts a milder upcoming winter. So exactly where the darkest band is present on this caterpillar, that's how that indicates when in the winter the worst of the conditions will be.
So, and of course, there's never just one version of these old wives' tales or folklores that you always hear about. There's one more version about how relies on how thick the coat of the woolly bear caterpillar is. When they have a very thick coat, it means that it's going to be another cold and snowy winter. But I'm pretty sure that there's a third one, isn't there, Bethany?
Yes, there is. It's said that the woolly bears crawling in a northerly direction is actually trying to escape the cold winter. And the cold conditions north. On the other hand, woolly bears crawling on a northward path would indicate a mild winter.
Ah, that's pretty interesting. So did you also know that there are some festivals that people honor the woolly bear caterpillar with?
That is crazy. And I mean, this woolly bear caterpillar, it's so popular that there are many festivals, in fact, that occur to honor this caterpillar. So ever since 1973, the residents of Vermilion, Ohio, produced this festival that consists of parades. They take out their caterpillars and then they produce a local forecast where they take the coloring of the caterpillar and they say what the winter is going to look like. So
it's kind of like when they take Punxsutawney Phil out of his hole and see if he sees a shadow or not. I want to know how some of these got started. That's pretty crazy. So if you see really one of these crawling around, it's probably trying to search for that perfect spot to curl up and spend the upcoming winter, whether it's under a tree, a rock, or a nearby tree. But I mean, if I'm a caterpillar, like I'm probably gonna get into my cocoon to go out for the winter, get ready to turn into a butterfly for the spring.
And you know, it's actually funny, those pictures that we showed earlier of those two woolly bear caterpillars, I saw those right outside of my house. So I just had to take a snapshot of those pictures because I had never heard of this myth before. And when I saw them, I was like, wow, I mean, this must mean we're having a more mild winter because the brown stripe is actually longer than the black. So
Bethany, you ever hear of this before?
Yeah.
I actually have heard about it. I grew up in Buffalo, and that was how we deemed how bad the lake effect was going to be, actually. But like here, I've found that most people haven't actually heard of it in Oswego.
Did you ever find that it was right?
Probably not. Not in Buffalo, no.
Well, you know Buffalo, it's a pretty crazy town up there with the lake
Yes.
effect. So coming up after the break, we'll have one final check on the weather with meteorologist Dan Maslowski. Don't go anywhere. We'll be right back.
welcome back to Weather-Wise. Joining us at the Weather Wall is meteorologist Dan Maslowski.
So Dan, what are we expecting for the rest of this week and heading into the weekend?
Well, we do have a lot going on. One thing that I wanted to talk about was these rain showers that are making their way into the area. Looking at radar and satellite, we do see those showers, and they're going to be making their way into tonight and tomorrow. So make sure you grab that umbrella before you head out the door. Taking a look at temperatures, it is fairly mild. We do have mid 50s to upper 50s, and there are some places that are pushing into the 60s, such as Fulton at 60 degrees. We have Oswego at 56 and Pulaski at 59 degrees. It's fairly consistent across the region, mid to high 50s, and we do have areas like Albany that's actually pushing into 62 degrees, so it's one of those hot spots. And we're going to time this out for you. So looking at the futurecast, we have Wednesday, 11:30 p.m., those showers are making their way across the region. Now, as we get into Thursday, 12 p.m., that's when we're going to have the thick of the showers making their way across the region. As we fast forward, we get into Thursday, 4:30 p.m., and that's when we still have those showers, but they're going to be making their way across the region. We still have some more rain. Most of it is going to be in Rome, where you see those those orange and those yellow spots. Those are where you're going to have the highest rainfall amounts. Now we're going to get a little bit further. We actually have some snow that's to the north of us that could be making its way into our area. And we do have some watches and advisories. Now, taking a recap, we do have scattered showers, 55 degrees, winds coming out of the southeast, 20 to 30 miles per hour. That is pretty large. Now back to you guys at the desk.
Hey, thanks Dan for all that good weather information. It's been a pretty wacky week of weather. We're expecting a pretty rough Halloween. Do you have any words on that? On what what Halloween might be like?
For me, I think Halloween's going to be pretty good. I know we do have those rain showers that are making their way into the region, but I still think it's going to be fun. You know, it's how you make it.
Yeah. So I mean, I've heard a lot of places have actually moved Halloween. Some towns have really started to push Halloween to different days. But unfortunately, that's all the time we have this week. Thank you again for joining us, everyone. We'll see you again next week, where we will continue to make you weather-wise.
Have a good night and have a happy and safe Halloween tomorrow.